All right, here we are. This is the last section in this chapter that we're going to cover. So this section, it looks similar to the previous ones we've looked at. Section 5.1 was systems of linear equations. Section 5.4 was systems of nonlinear equations. But the difference between those sections and this section is that those sections, we were dealing with equations, which means there was an equal sign. Here we go, oh, what if one of those or both of those equations turned into inequalities? So instead of seeing an equal sign, what if we saw a greater than or a less than or a yada yada yada? And that sounds complicated, and it is very complicated, but it's so complicated to where we can't really solve, because once you turn an equation into an inequality, a system of inequalities has infinitely many solutions. So, and of course you can't really solve if there are infinitely many solutions. The best you can do is just graph. So that's what this section's all about. It's like, okay, we know there are infinitely many answers. We can't list them all, obviously, because they're infinite, but at least we can just draw a picture of them, and then we'll kind of know where they are looking at the picture. So, okay, we will actually see a few applications of this, so it's worth kind of talking about what it says here. Does your weight fit you? That's kind of interesting. Let's see, the chapter opened by noting that the modern emphasis on thinness as the ideal body shape has been suggested as a major cause of eating disorders. Come on, no shit. Okay, sorry, I had to curse there, but come on, duh, what else would it be? Anyway, in this section, the textbook will demonstrate how systems of linear inequalities in two variables can enable you to establish a healthy weight range for your height and age. Okay, so that's what's going on here. It looks like, and we will see an application of this a little later in this same section, so it's good to kind of see what's going on. It looks like when we're talking about these linear inequalities, the height is the x value, so the person's height, I guess that makes sense. The taller you are, the more you should weigh, that makes sense. And the weight is the y value. Okay. So I guess the shaded area represents the weight range that you could be in to be healthy. And that's another thing, is like, you can't compare your weight to someone else, because some people have bigger bones than others. If you look at, some people have really thin wrists, for example. Some people have thicker wrists. It's just, yeah. So you can't just say, oh, I should weigh the same as that person. Whatever. So that's da-da-da. And that's for men and women aged 19 to 34. But okay, I guess it's a different thing going on if you're age 35 and older. Okay. Interesting. So we'll come back to that in a couple objectives from now. But first, we just want to know, how do you even graph linear inequalities? Because if this was something I was studying, my job, I guess as a psychologist or what, I don't know, I guess you'd probably be more in the medical field, huh? But if this was my job to study this, what is the healthy weight range, I'd probably want to be able to graph this to see what kind of weight range is healthy or safe or whatever it is. But I got to know how to graph these things. So that'll be the first thing we'll do, is learn how to graph. How did they get this graph here? We'll look at that, and then we'll see applications in real life. So this first objective is we're going to be able to graph a linear inequality in two variables. So the steps are outlined here. But right now we're just going to start with one linear inequality. So like this guy here, let's see, 4x minus 2y greater than or equal to -8. Positive 8, what the hell? But this guy, the one that's in this application, it has two lines actually. There's one here and there's one here. So we're kind of building up to that. We want to be able to graph a system of inequalities where there's maybe two lines or two circles or whatever it is. But we're building up to that, so we're going to just start with this one. So okay, if you have a linear inequality like this guy, the first step you want to do is isolate y and graph the resulting line using slope and y-intercept. So let's start with that. Okay, let me see. Off to the side, I'm going to try to kind of move off and try to isolate y. So we want to go, okay. If I want to isolate y, I guess the first thing I would do is probably move the 4x over. So I'll subtract him. So now it's, okay, come on. -2y equals greater than or equal to. And I could write 8 minus 4x or -4x plus 8. I think I'm going to go with the latter because, like it says, I'm gonna want to use the slope and y-intercept here. So I want it to look more like y equals mx plus b. And then the last step would be divide both sides by -2. Every single term, since there are three terms, all three of them get a -2. But notice that I divided an inequality by a negative number, which means I have to flip the inequality. Remember, back when we learned how to solve inequalities, we learned that if you multiply or divide by a negative number, you have to flip the inequality. If it was a greater than, now it's a less than. If it was a less than, now it's a greater than. So now instead of being y greater than or equal to, it's y less than or equal to. And here it was negative 4x divided by negative 2. That becomes positive 2x. And a positive 8 divided by negative 2 would be negative 4. Just got to be a little bit careful on your algebra there. That could mess up your line. So it looks like the y-intercept is negative 4. And the slope is 2. So I'm going to graph that line. If I have a y-intercept of negative 4, that means I put a point at negative 4 on the y-axis. There he is. And the slope is 2, which is 2 over 1. So I'll rise 2, run 1, up 2, right 1. There we go. And I'm going to just make a line through that. But we'll see that I should be careful, because what does it say in this description? It says, okay, isolate y and graph the resulting line using slope and y-intercept. If the inequality contains an or equal to, like ours does, notice it was a greater than or equal to, it ended as a less than or equal to, but either way, it has an or equal to, use a solid line like we did. But if it were to not have an or equal to, if it was just a strictly greater than or a strictly less than, I would actually use a dashed line, like, I don't know if you remember when you were a kid, it said, oh, cut along the dotted line or the dashed line. That's kind of what you'd be looking at. So I should have been more careful when I graphed that line. I should have thought, is there an or equal to in this inequality or not? Because I guess the or equal to means that points on this line are points that I want. So that's why I made it solid. But if it was just a strictly greater than or a strictly less than, that means I only want points that are above or below this line. I don't want points that are on the line. So I put a dashed line to show that I don't want anything on this line. This is just like the border between the points I want and the points I don't want. It's sort of the idea. And then step 2 says, if the inequality is a greater than or equal to, so basically your inequality is facing this way, it's either that or that. Then you shade everything above the line, but if it's a less than or equal to, I shade everything below the line. So let me see, what are we dealing with here? When we got to the end, once we isolated y, we were left with a less than or equal to, because we had to flip the inequality. Equal to. So that means we shade everything below the line. Below the line. Alright, so I want everything on that line, which I've already plotted. But then I want to shade everything below, so you just kind of like color it in, as best you can. It doesn't have to be perfect. Just something like this. There we go. And that's the idea, yeah. So let's try to do that on this next one. Once you do it a few times, you kind of get the hang of it, and you'll probably never forget it for the rest of your life. Unfortunately, your brain will be full of things that don't really matter like that. So okay, we want to isolate y. That was the first step. Okay. If I move the x over, then I'm left with negative 2y greater than, and I could put 10 minus x, but I'm going to write negative x plus 10, so it looks more like mx plus b. And then the last step would be divide by that coefficient, negative 2. Every term, all 3 terms should get that negative 2. But like we said before, now I divided both sides by a negative number. I need to flip the inequality. I started out as a greater than, but it becomes a less than. So I gotta flip this guy. Now it's y less than, okay. So it's like a negative x divided by a negative 2. That's a positive x over 2. And then positive 10 divided by negative 2 is negative 5. And if you want, you can rewrite this guy. This is y less than, just to make the slope more obvious, I'm going to write a half x minus 5. Because that's really what's going on here. If you want to kind of extract the slope out of the x term. So the y-intercept should be negative 5. Y negative 5. And then the slope is 1/2. I'll put a point at negative 5 on the y-axis. There he is. And then I'll rise 1, run 2. Up 1, right 2. Okay, that looks good. And then, but before I draw the line, I should think, is this going to be a solid line or a dashed line? Well, the inequality had no or equal to. This has no or equal to. It's a strict less than. It's not less than or equal to. So it'll be a dashed line. I'm surprised that I thought of that before I drew the line. Usually I draw the line and then I say, oh wait, should that have been dashed? Oopsies. But actually this time I remembered. So this should be a dashed line. Just to show that this is going to be the border between the solutions I want and the solutions I don't want. And in this case, I don't want any points on the line. That's why it's dashed. Alright, now I'm either going to shave above or below the line. It depends on this inequality. But since this is a less than, I'll shade below the line. Below the line. And the way I remember that is I just think, this is showing me that y is less than something. So where are the y values that are less? You know, the smaller y values, they're down below, you know. But if it was y greater than, where are the greater y values they're above? So that kind of helps me remember which way I want to shade. In this case, I want to shade below the line because it was all the y values less than stuff. So there you go. You're kind of drawing, yeah, so the line, you're kind of drawing the border, and then you're either shading above or below it depending on how the inequality ended up. So let's try this guy. This guy's kind of tricky because there's no x value. But remember, if you think of this as an equation, what if it was y equals 1? That's actually, what is it? A horizontal line. So we're going to draw a horizontal line through 1, but it's going to be a dashed line because the inequality has no or equal to. Inequality has no or equal to, you know, it's just a strict greater than. So, okay, so I'll put a dashed line at y equals 1. He looks like this, I guess. Blah, 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 something like that. There he is, and I'm either going to shade above or below, but notice it shows y greater than 1. So we said greater than means you're shading everything above that line, or you can reason it out in your head. Where are all the y values that are greater, the larger y values? They're above or high, you know, upward. So it's everything above that line, y equals 1, is what I want as my solution. Beautiful. Alright, let's try this one. This one's a little different because it's an x as well. But like we did in the previous one, imagine that was an equal sign, x equals 1. That's a vertical line. This one, though, has an or equal to, so I'm going to make a solid line. It's solid because the inequality had an or equal to. Alright, so that's the first thing. I'm going to draw a solid line that's vertical through x equals 1. There we go. Something like that. Alright, and then I'm either shading one side of the line or the other. There's not really an above or below since it's a vertical line. So I'm just going to reason it out. This is what my inequality was. So I want all the x values. I want x values less than or equal to 1. So which side of that line are all the x values less than 1? They're on the left, you know. Smaller x values are on the left, larger on the right. So if it was an x greater than or equal to, I would shade on the right because those are the larger x values. But we got a less than or equal to, so I want all the ones that are on the left. There we go. That's it. So it's kind of intuitive, I guess, you know, sort of. But now our next objective we're moving on to is we're not graphing linear inequalities anymore. We're graphing nonlinear inequalities. So those are a little different, a little more complicated, obviously. As we saw, the systems of linear equations from section 5.1 were easier than the systems of nonlinear equations from section 5.4. But let's see. So this, for example, is a nonlinear equation. If you were to make that an equal sign instead of a greater than, that's the equation of a circle. That's exactly what we're going to do first. The first step is graph the nonlinear equation resulting from changing the inequality symbol, which in this case is a greater than, to an equal sign. So we're going to rewrite this as x squared plus y squared now equals 25 instead of greater than. And then we're going to graph that equation. So this makes you kind of dig back to what you knew before. How do you graph the circle? How do you graph a parabola? How do you graph a line? You know, all that stuff. Now this is a circle centered at the origin at 0, 0. Because remember, it would be centered somewhere else besides the origin if it was looking like x minus something squared and y minus something, you know, that's when it would be centered somewhere else. But there's no numbers inside parentheses with x or y, so the origin is going to be your center. And then the radius is always the square root of the number on the other side of the equal sign, so 5 in this case. I'm just going to graph a line that has a circle of radius 5, or not a line, sorry. Graph the circle of radius 5 centered at the origin, but the same thing goes, since there's no or equal to here, it's going to be a dashed circle. No or equal to, so it'll be a dashed, that sounds weird, dashed circle, but yeah. So don't draw a solid circle, make it kind of dashed. All right, so it's going to have a radius of 5. Let me see. I'm just going to kind of draw it going as high as 5, as far left as -5, as far down as -5, and as far right as 5. And then I'll just kind of draw a dashed circle around to hit those points as best I can. Try to round it out. It looks okay, I guess. There we go. Sure. Whatever. Looks all lopsided, but hey, it's not perfect. Who cares? And then what happens now is, like, you know, with the lines, we either shade above or below the line, or to the left or to the right of it, whatever. Here, this is a circle. We're either going to shade everything inside of it or outside of it. Your shape, your line, or your circle, whatever it is, it's kind of like the boundary between the solution and the non-solution. So it's either going to be inside of the circle is the solution, outside's not the solution, or vice versa. But then the second step tells you which one's which. So what we're going to do is choose a test point on one side of the graph. So either a point inside the circle or outside the circle to test in the original inequality. Well, personally, my favorite point in the whole world is 0, 0 because it's so nice. So I think that's what I'll do is I'm going to test 0, 0. You can test any point on the whole coordinate system as long as it's not on your graph. You know, I can't pick, for example, 5, 0 because that's on my circle. I want to pick something either inside or outside of it, not on it. But every time 0, 0 is a candidate, I definitely do that. So I test it in the original inequality, not when I change it to an equal sign, but when it was a less than or a greater than before. So I'm going to put 0, 0 in there. It's going to be 0 squared plus 0 squared. And I'll see, is that greater than 25 or not? And you can probably do this in your head. You can imagine what's going to happen. The left side's 0, the right side's 25. 0 is not greater than 25. That's false. So, okay, what do we do in that case? It says, if the result is true, you want to shade the side that does contain that point. Well, we did not get a true. We got false, so if false, shade the side that does not contain that point. Okay, so we're either shading inside the circle or outside. Since that point, the origin was inside, we don't want that because we got false. That means we want outside. We tested something inside, we got a false statement. That means that was bad. We want everything outside. So, you know, I tested 0, 0, the origin, but if you tested a point outside, like, I don't know, 10, 0. 10, 0's, let's see, where's 10, 0? He's way the hell out here. I don't know if you can see where I'm putting a point. This guy. So if you were to test 10, 0, you would have got a true statement, which means, yes, this is the correct side of the circle. I want to shade the side that has this point, which is outside. It's kind of interesting. It looks a lot different, and the process is a lot different, than the lines. So let's see. Let's try this guy. This, though, yeah, you really got to dig deep back into your knowledge of graphs. I'm going to do the same exact steps because this is not a line. I'm going to first change the inequality symbol, the less than or equal to an equal sign, and then graph this guy. This is a parabola. And it's easier to recognize how to graph it if you switch those terms. I'm going to write it as -x squared plus 5. So remember, the basic parabola looks like what? Let's see. Let's see. Y equals x squared looks like this. So this is just a variation of that. The negative makes it reflect across the x-axis, so it'll be kind of an upside-down parabola. But then the 5 makes it move up 5 units. Up 5 units. So it's more going to look like, let's see, up 5 units, and then facing downward it's going to go like something like that. Although, why am I doing it dashed? It's actually a solid parabola. Sorry. Something like that. And why is it solid? Because there was an or equal to in the original inequality. Or equal to. So the graph is solid, not dashed like the circle we just drew. It's going to be solid. So we got that. And then the second step, and the last step, is you're going to choose a test point that's on one side of this parabola or the other. Test it and see if it's true or false. So we're either going to shade everything inside this parabola, or I guess contained below this parabola, sort of, or everything outside. So I always choose 0, 0. I'll just check, is 0, 0 the origin not on the graph? Yeah, it's not on the graph, so I can choose it. I would just say always test 0, 0. Unless 0, 0 is on the graph, then you have to choose something else. But you're free to choose any point in the whole coordinate system, as long as it's not on the graph. Let's see, what did the original inequality look like? It was y less than or equal to 5 minus x squared. Okay. There we go. So I'm going to put a 0, 0 in there. Y is 0, X is 0. We'll see if it's true or false. Like we said, if it's true, you want to shade the side that had that point. If it's false, you want to shade the side that did not have that point. So it's 0 less than or equal to, that's 5 minus 0, which is 5. 0, is that less than or equal to 5? Yes, that's true. So I'm going to shade, like we said, the side containing my test point, which was 0, 0. 0, 0. Okay. 0, 0 is the origin, so that was kind of like inside or below the parabola, I guess you could say. This one. So I want everything that's kind of inside or contained within this parabola. But if I had gotten a false, that means this is what I don't want, so I'd shade the opposite, what's outside or above this parabola. Kind of wild, huh? In a good way, though, right? Alright, let's see. We got a couple more objectives, and then this section's pretty much over, so then we'll start a new chapter. So we want to use mathematical models involving systems of linear inequalities. Okay. This is kind of going back to the introduction to this section. This might be something that talks about healthy weight range. So this says, healthy weight range for men and women ages 19 to 34 can be modeled by the following system of inequalities. And they definitely don't explain where these inequalities come from. I'm sure it's some kind of, I don't know, some kind of medical jargon that I don't understand. Never, though, if it matters to you, I don't know. What was X? It was the height, that's right. The height of the person, and Y was the weight. Okay, so we just want to know, how do you test to see if a point is actually in the solution? Well, remember what we did before in the previous section. If someone gives you a point and they say, is this a solution to the system? You just substitute it in and see if it's true or false. So in order to be a solution, though, just like before, substitute. It better be a solution to both of those guys. So I'm going to substitute into the top one that they gave me, this guy, and the bottom one, substitute. 3.7 x minus y less than or equal to 125. So I'm going to put 66 for x. Let's see. X, oh, did I do that right? Yeah. X equals 66 and y equals 130. And if this is a solution, I better get a true for both of them. So I'll put a 66 here, and a 130 here, a 66 here, and a 130 there. Let me see if I get true for both. See, this is 4.9 times x minus y. Let's see, I have to use my calculator here. I definitely can't do that in my head. What's 4.9 times 66? That's 323.4. That is subtracted by 130. And I want to see if I get something greater than or equal to 165. I do. I get 193.4. That is greater than or equal to 165. So far, so good. That does look like a solution. True. Okay. Now I'm substituting that point into this other equation, or sorry, other inequality. And we'll see if this guy's true. What's 3.7 times 66? It's 244.2. And I'm supposed to subtract 130 from that, and I want to see if whatever I get is less than or equal to 125. Let's see. It is. It's 114.2. That is less than or equal to 125, so I get a true. Alright, since it's true for both, that means that 66, 130 is a solution. So which they didn't really ask, but that means that someone 66 inches tall and 130 pounds, I guess, is in a healthy weight range. That's 5'6", huh? Okay. So if you're 5'6" and you're 130 pounds, then you're healthy. Interesting. Alright, let's see. Then, the very last objective now is a system of equations. We haven't seen that yet. Or sorry, a system of inequalities. The good news is it's not much different from what we did before. Notice these are both lines, or this is a linear equation. It's not, if you change that less than to an equal sign, it's a line. Same thing with this guy. If you change that greater than or equal to a equal sign, that's a line. So all we're going to do is graph both of these linear inequalities. Let's see, I'm going to write this down. Graph both linear inequalities. As in, was it objective 1 where we did that? I think it was. Is that what we started with here? Let me see. Yeah, Okay, so just like we did in objective 1, sorry, oops. As in objective 1, but the overall solution that we're looking for is where the shading intersects. So like, for example, if we graph the yellow highlighted one, you know, this top one here, it's going to give me some kind of a, I'm going to shade above or below that line, and then the green kind of highlighted one, that guy is going to be a similar thing. So where you see the yellow and the green on top of each other, that would be our solution. So let me see, and you know what, maybe it'll be easier to see if I make this, oh god, let me erase here, sorry. Yeah, I think to make this more obvious, I'm going to make the second one purple. I think it's easier to see where yellow and purple intersect, maybe, or pink, whatever the hell. But we have to kind of treat these separately. So I'm going to first look at x minus 3y less than 6. I'm going to graph that guy first. But what we said in the first objective is you have to isolate y and then graph the resulting line. So I'm going to move the x over. Okay, that'll mean negative 3y, less than, not equals, negative x plus 6. And then I'll divide by negative 3 to get rid of that. But that will force me to flip the inequality symbol as we've seen before, and I can rewrite this as 1/3 x minus 2, because this is 6 divided by negative 3. And this is a negative divided by a negative. So my y-intercept is a negative 2. Let me see, I'm going to start there. Let's see, negative 2 here, negative 1, negative 2. And then my slope is 1/3, so from that negative 2, I'm going to rise 1, up 1, and then go to the right 3. So there's my second point. But based on the inequality symbol, there's no or equal to, so it's going to be a dashed line. Okay, there we go. Just do as best you can, you know. There we go. And then based on the inequality symbol as well, it's a greater than. So I'm going to shade everything above the line, because I want all the y values that are greater than this line, which means I want all the y values that are above it. Oops. And I'm going to use the same color as the highlighted, because we highlighted the equation in yellow. So I want everything above the line. I'm going to shade everything in yellow that's above the line. Okay, looks good. So it's kind of like, so far we've just done a problem like we did in objective 1. But now, all of a sudden, there's a second inequality. I'm going to have to grab that one and graph that just right on top of this as if what I just did wasn't there. 2x plus 3y greater than or equal to, what is it, negative 6. Okay. So what we have to do, the same kind of thing, is I'm going to graph this guy, so I have to solve for y. Let me move the 2x over. So it's 3y greater than or equal to negative 2x minus 6. Then I'll divide both sides by 3. This is the first time, though, that we've seen I do not have to flip the inequality because I didn't divide by a negative. I just divided by a positive. And here it's 6 divided by 3 is 2. So it looks like my y-intercept will be negative 2 again, same y-intercept, so I got pretty much the same point I'm starting out with, but the slope is negative 2 over 1, so I'm actually going to go down 2 from there. Or sorry, did I say 2 over 1? I meant 2 over 3, sorry. Down 2 from there and then 3 to the right. And this one, though, this inequality has an or equal to, so I'm going to do a solid line this time. The other inequality had a strict, strict less than, so it was strict greater than, so it was a dashed line. Now I got to figure out, do I shade above or below that line? Since this is a greater than or equal to, y greater than means I want everything above this line. So just try to disregard the yellow. Everything above the red line is all this stuff here. All this crap. Whatever. Here we go. I want all this crap right here. So now you can kind of tell the solution is where they intersect. That would be this area over here. Solution. This whole, like, top, I guess, triangle. Yeah. So really this is not a solution. This yellow and this pink is not a solution. Solutions, because you only want where they intersect. So technically, if you're doing your homework, what you should do is, you plot those two lines. Okay, let's say the first one looks like this. I'm just kind of doing it fast, and then, it's dashed. Whatever. Second one looks like this, But when you shade it on the homework online, you only shade the solution where they intersect. So be careful, you should probably try this on a piece of paper first, just to get the feel for it and the perfect answer. But once you're down to the homework, this is what you should only see. You should see no shading on the left or the right, only the above, because that's the intersection part. All right, let's try that one more time on this other problem here. So I'm going to take, like we saw before, I'm going to grab one of them. Just start with 1. Let's see, y greater than 2x minus 3. And that one's actually good because y is already isolated. So I think I can just go ahead and graph that guy. Let's see. I'm going to go like this. 1 and okay. Let me get the xy coordinate system going here. There he is. There he is. So I'm going to start with -3 is the y-intercept. There we go. Okay, somewhere around there. And the slope is 2, so I'll think of it as 2 over 1. I'm rising 2 and running 1, so I'd be somewhere around here. This is a strict greater than. There's no or equal to, so this will be a dashed line. All right, looking good. Now I have to determine, am I shading above or below this line? Well, this is, what's it called? It's a greater than symbol. I want all the y values that are greater than this line, so everything above this line. So all this area is, I guess, technically above, even though this is a really steep line. There we go. And if you're ever not sure, okay, what's above and what's below the line, I don't really know. You can do like we do with the nonlinear ones from objective 2, I believe it was. And actually choose a test point, choose, say, 0, 0, test it, and I think you'll get the right thing. And now we'll do the same with the second inequality. It was y less than -x plus 6. Thankfully, y is isolated already, so I don't need to do that. I'm just going to try to graph this guy. Let's see. So y less than, okay, the y-intercept is 6. Let me find that guy. 1, 2, 3, 4, 5, 6, somewhere around here. And then the slope is -1. If I put that over 1, though, I'm rising -1, which is down 1, and running +1, which is to the right 1. This is also an inequality symbol that does not have an or equal to, so this one has to be dashed as well. So you look something like that. Something like that. Okay. Then I look at the inequality symbol also. Since it's y less than that line, I want to shade the side of this line that's less than. Where are the y values that are less than this line? They're below the line. So I want everything below the line. Let me see here. All this crap right here. Sorry, just kind of. All right, there we go. So there's our solution. The solution is where they intersect. So like we said before, technically this is the solution here. Solution. Only this green or the leftmost triangle. This is fine. Like if you did that, if that's exactly how it looked on an exam, I'd be fine with that. As long as you outlined where the solution was, because I'm not sure if you know where the solution is. But like I said, on the homework, what you would do is your lines would look like this, blah, 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 blah. But you would only shade that solution area. You wouldn't do the separate shadings. They only want to see the real solution where they intersect. So I would definitely encourage you to kind of use some scratch paper on these. Don't just do all the stuff online, all the math. I would try to write this down and graph it, and then you can graph the rest. But hopefully that all made sense. That's the end of chapter 5, right? Now we're going to move on to a new chapter in our lives. We're going to dabble a little bit in chapter 7, and then we'll look into chapter 8, and then we're all done. It's kind of sad, huh? Try not to cry. There are more math classes to have fun in. But thank you for listening. I'll talk to you in the next video. Sorry if I bored you too much.